pH is 5. Now, some of you didn't, you got to get questions like this on the test. Some of you can see that did some of these or tried to do them, and others like, what are you talking about? What's pH of solution that has a base concentration of 10 to the minus 8 moles per liter?
8.
8. Okay. Is it 8?
And you're going to use whole numbers.
What?
Right?
Yeah. Is it 8? Is the answer to number 5 8? No, the answer to number 5 is not 8. It has a base concentration of 10 to the minus 8 moles per liter. So what is the hydrogen ion concentration? What? Hydrogen ion concentration is 10 to the minus 6, because both of them have to add up to 10 to the minus 14. So the answer to number 5 is 6. Everybody see what I did there? Because it says, what is the, if it's a base concentration of 10 to the minus 8, then the hydrogen ion concentration is 10 to the minus 6. 6 and 8 are 14. Okay, that's not a tricky question. A solution A has a pH of 5. A solution B has a pH of 9. Okay? Which is more acidic? 5 or 9? Okay, 5. All agree on that? Which has the higher hydrogen ion concentration? Which one of them has the higher hydrogen ion concentration? 5 or 9? 5. All right. How much greater is the hydrogen ion concentration than the lower one?
4.
How much greater is the concentration?
4.
What? She said 40 times. Okay.
No. 10, 100, 1,000.
Where did you get 40?
10,000.
10 plus 10 plus 10 plus 10. Okay?
10 plus?
You were,
Oh, I thought it was
you
10
were
times.
hitting the right idea, but a little bit off. Here's a pH of 5, a pH of 9, pH of, 6, 7, 8. All right. Now, how much greater hydrogen ion concentration is this than this? It is 10 times greater. 10 times greater. Okay. How much greater is this than this?
100.
10 times greater. So how much greater is this than this?
100.
100. 10 times 10. This is 10 times this, concentration-wise. So from here to here would be what? 1,000 times greater. 10 times 10 times 10. This is 10 times greater than this. So how much greater from here to here? 10 times 10 times 10
It's
times
not right,
10,
right?
which
It's
is
missing one.
what?
10. Oh, no.
10,000. It's 10,000 times greater hydrogen ion concentration. For each pH unit, it's a 10-fold change, either up or down, depending on which way you're going. On the back, a buffer system must be able to function as what?
An acid or a base.
Acid or a base, well, basically an acid and a base. But-
Yeah.
Okay. All right, we already did this one about the relationship between pH and enzymes. I have a 1 liter solution, 1 liter of a solution which has a pH of 3. Okay? If I add water to this solution, what will happen to the pH?
Nothing.
Will it go up or down?
Won't change. Oh,
Will the
yeah.
pH go up or down?
It
What
would
am I
go,
doing
it would go
to the
down.
solution?
It would go down. It would go down.
Wait a minute, wait a minute. Look, these are meant to be very simple questions. If I
Yeah,
have
but
a
we added
solution,
water.
right, let's say it's a sugar solution, and I
Oh, we
add
added
water
vinegar.
to it, what do I do to the concentration of the sugar? Concentration of the sugar is going to decrease, of course. Follow that? No, let's do it. I think people sometimes just kind of jump at some conclusion and without thinking. All right, here's my sugar solution. And it has some concentration, whatever that concentration is. Concentration is. All right? And I add water to it. What will happen to the volume of this solution? Volume will go up. Everybody agrees that? Volume will go up. What will happen to the concentration of sugar? It will go down because I have the same amount of sugar in a greater volume. So the concentration goes down. So, if I have 1 liter of a solution which has a pH of 3, if I add water, the pH will go down. I'm decreasing the concentration of what? Sugar. What? I'm decreasing the concentration of what? Has a pH of 3. I add water, increase the volume. We all agree that the pH will decrease. Why does it decrease? Because the concentration of what is going down? Hydrogen ions, right? Because that's what's changed by making the pH change. Okay. Solution A has a pH of 10. Solution B has a pH of 7.5. Says, describe the relative and absolute condition. What does that mean? Well, you can talk about pH in a relative and absolute sense. With a pH of 10. All right. Is that an acid or a base? It's base. I agree it's base. Here's a pH of 11. Now, both of them are what? Bases. The pH of 11 is more basic than the pH of 10. The pH of 10 is less basic than the pH of 11. Okay? The pH of 10 is more what than the pH of 11? It's more acidic. Even though it's not an acid, it's more acidic than the other one. All right, that's what this question is talking about. If I had a pH of 5, I could say in an absolute sense, that is what?
More acidic.
That's an acid, right?
No.
I agree? Less than 7. Suppose I had a pH of 4. I can now say that the pH of 5 is less acidic than the 4, right?